Welcome. In this video, we will delve into advanced indexing strategies in SQL, specifically covering indexes and the differences between clustered and non-clustered indexes. Indexing is a database optimization technique that improves the speed of data retrieval operations on a database table. By creating indexes, you can significantly enhance query performance. There are several types of indexes, including unique indexes, composite indexes, and full text indexes. Choosing the right index type is crucial for optimizing performance based on your specific query patterns. A clustered index determines the physical order of data in a table. Each table can have only one clustered index because the data rows themselves are stored in the order of the index. Let us look at an example of how a clustered index works. Non-clustered indexes are separate structures that store a pointer to the actual data. A table can have multiple non-clustered indexes, which allows for faster lookups without rearranging the actual data. Here is an example of a non-clustered index in action. A covering index is an index that contains all the columns needed to satisfy a query, allowing the database to retrieve data solely from the index without accessing the actual table. This can significantly improve query performance. Let us look at a covering index example. Covering indexes are particularly beneficial for frequently queried columns or when performing complex queries with multiple columns. However, they can increase write overhead, so it is essential to evaluate their trade-offs. Clustered and non-clustered indexes serve different purposes. Clustered indexes are best for range queries and data retrieval in sorted order, while non-clustered indexes are ideal for quick lookups. Understanding these differences helps in optimizing database performance. While indexes improve read performance, they can slow down write operations due to the overhead of maintaining the index. It is vital to strike a balance by analyzing query patterns and indexing appropriately. In conclusion, understanding advanced indexing strategies, including covering indexes and differences between clustered and non-clustered indexes, is essential for optimizing SQL query performance. I encourage you to implement these strategies in your database design. Thank you for watching. Need your comments, subscribe and share.